Hi, I'm Mark Goodner, a program manager on the Visual Studio team. Our goal for Visual Studio is to be relevant and useful to every developer. I'm going to show you an example of how you can benefit from Visual Studio with any C++ code base, regardless of compiler, build system, or platform. I'm going to show you that whatever tools you're using, you'll be able to integrate them with your daily Visual Studio workflow. It all starts with the new capability of Visual Studio 2017 to open code bases without creating a Visual Studio project or solution. You can simply use the new menu option, Open Folder, and browse to the root of your codebase to open it in Visual Studio. The codebase could be using any kind of build system. For example, Makefiles, Gradle, Scons, your own shell script, whatever. Visual Studio 2017 also introduced native support for CMake codebases. So if your codebase is using CMake, you will get an even richer experience without extra configuration. If you're not familiar with CMake, it's an open source build system that manages your build process using a compiler and platform independent approach. To be clear, this is not a one-way CMake generator to create Visual Studio projects. There are no Visual Studio projects here. You're working natively, directly with CMake. Clone a repo and open the folder in Visual Studio. It's that easy. As you make changes to your CMake scripts or C++ code, Visual Studio will keep up with you by automatically configuring CMake in the background. You no longer need to generate Visual Studio project files manually. You can work with your code as it is. Push your changes back without asking your colleagues not using Visual Studio to change anything for you. Let's go take a look. All right, let's get started by opening a folder. In this case, I've cloned the Bullet3 repo, which is a physics library for games. We've forked it to make some small changes to one of the examples to highlight some Visual Studio capabilities. Looking at cmakelist.txt here, you get colorization and outlining as you'd expect. We have some menu items that are CMake specific, as well as some context items over here. And you can build and debug your CMake targets. Of course, you get seamless IntelliSense for your C++ files that are part of the CMake project. This codebase through CMake has different configurations, which you can see here. One of them is a MinGW configuration. In a nutshell, MinGW is an open source environment for creating Windows ports of Linux applications using the GCC toolchain. There are good reasons to choose to target Windows by using MinGW. For example, your code is not truly cross-platform. Let's choose this target, which I've configured to use the GDB debugger that MinGW requires and that Visual Studio supports out of the box. So there's our app running. Now I set a breakpoint that will be hit when I close the application. And there we are. We're back where you can see the richness of our world-class debugger in Visual Studio. So if you're using MinGW, I hope you can clearly see which IDE just became the best one for you to use for your development. Another reason someone may have chosen MinGW is to use the GCC compiler. A likely reason would be that in the past we had many conformance gaps in the Microsoft compiler, MSVC. That's no longer true. MSVC is conformant with the C++ 11 and 14 standards, and with the upcoming release, the C++ 17 standard. This codebase builds with our MSVC compiler, so you can target Windows directly instead of through MinGW. I can switch to that from this C++ configuration dropdown, and now any building or debugging would be using this other configuration. That's how easy it is to change targets. Here's the use of const_expr. What I want you to see isn't that our compiler can build with this. Of course it can. What I want you to see, though, is that in supporting standards in our compiler, we also make sure our industry-leading C++ language service shines in the IDE. Notice how the tooltip here, at design time, calculates the value of the expression without having to run or debug to see it. I can even change it live, and it evaluates. You won't find that in many other tools today. So in this project, someone may have started by porting a Linux codebase to Windows first via MinGW, and then switching to our MSVC compiler and targeting Windows directly. Every time you do ports like this, you want to rely on your unit tests for regressions. We've expanded our support for C++ unit test frameworks beyond our own to include Boost Test and Google Test in the box. Now, I ran my tests earlier, and I know this one using Google Test is failing amusingly because it's running faster than the test checks for. So let's just fix that by adding a line of sleep code here. So that fixes our unit test, right? Now remember, this is a cross-platform code base targeting multiple platforms through CMake. So when I make this fix in my Windows configuration, I need to make sure I haven't broken the builds for other targets. We know how easy it is to switch configurations. So I switched the target to Linux, and now you see red squiggles. So I can fix that like this. And now let's switch back to Windows and make sure that that's going to be good there too. So to target Linux, of course editing is important, but what about building and debugging? To do that, we need a Linux target, either a remote machine, the Windows subsystem for Linux, a VM, or a container running in Azure, or as I'll show you here, a local VM running so I can test this desktop app. To tell Visual Studio where to find and how to access your Linux targets, you use the Connection Manager from Tools, Options. The Connection Manager is where you can add and manage the list of your SSH connections to remote machines. Now I already have an entry here for my VM. When you have more than one connection, the first one in the list here is the default. If you try to run a build that needs a remote connection and you don't have one, you'll be prompted with this dialog to create one. We of course support password or certificate authentication. Now that this is all configured, I can build and of course debug. So let's switch back to Linux and launch my application. And now you can see the app running here on my Linux VM. A little bit slower, I'm sure just because it's a VM. Now I set another breakpoint earlier that's triggered on a mouse click. And look, there we are, back in Visual Studio with the full power of the Visual Studio Debugger. And that's how easy it is from Visual Studio to build and run on Linux, hit a breakpoint, and take advantage of the Visual Studio Debugger. I've just shown you in Visual Studio today MinGW, CMake, Linux, and leading C++ standard conformance. I didn't even get a chance to show you running remote tasks on Linux for using other build systems like Make, or our new ARM cross-compiler support on Windows. I hope that seeing and hearing about these capabilities that are part of Visual Studio makes the point. Any compiler, any build system, any platform, any open source tool you use, Visual Studio is your friend.